Okay, our example 2 for sound intensity says a sound wave reaches you with an intensity of 70 decibels and another sound wave reaches you with an intensity of 74 decibels. What is the combined intensity in decibels? So do we add them? Do we do 70 plus 74? That would be 144. That would be way too painful, right? So do we do 70 plus 74 or what do we do? This is also equivalent to asking the question, an earthquake with 7.0 reaches you, and then simultaneously another earthquake of a 7.4 reaches you, right? So I'm assuming that the intensity of the sound source when it reaches you is already 70, not that the original sound source was 70 decibels. So the sound source, whatever its intensity was released, and then when it reached you, it was already at 70 decibels, right? Same thing. Let's assume an earthquake, its original intensity, whatever it was, by the time it came to you, it was 7.0 on the Richter scale, and then another one, 7.4, reached you simultaneously. What would be the combined effect? 14.4? So not really, right? The way you're going to do this is you're going to solve for the actual intensity of the sound source in each case. You're going to add them up. Then you're going to convert back to the log scale. So you're going to do 70 is equal to 10 log of I over 1 times 10 to the minus 12. 74 is equal to 10 log of I over 1 times 10 to the minus 12. So divide by 10, and then you have raise both sides to the power 10, so 10 to the 7th. And then 10 to the power log cancels that. So you have I is equal to, so let's call this I1, 1 times 10 to the minus 12, cross multiply, then you're going to get I1 is equal to 10 to the 7th, 10 to the minus 12 is equal to 10 to the minus 5. That's watts per meter squared, right? Then you're going to do the same here, divide by 10, this will become 7.4, 10 to the power 7.4, right? And then raise this to the power 10, so you get 10 to the power 7.4. The 10 to the log cancels. You have I, 1 times 10 to the minus 12. And then 1 times 10 to the minus 12, the 10 to the minus 12 goes there, so this one becomes I2. I2 is equal to, just subtract it, 7.4, 10 to the power negative 4.6. These ones you can add like a regular scale. So we have I total is going to be what? 10 to the power negative 5 plus 10 to the power negative 4.6. Right? So how do you add them? This one you should do on the calculator. So 10 to the power negative 5 plus 10 to the power negative 4.6. That's going to give you 3.511886 times 10 to the negative 5 watts per meter squared. Right? So just do this on the calculator. You can't really add negative 5 to negative 4.6 or anything, right? You can convert this back to the log scale. So we can say dB is equal to 10 log of this number, 3.511886 times 10 to the negative 5 over 10 to the minus 12. Right? Well, what happens? Well, the 10 to the minus 12 again goes to the top and becomes 10 to the 12th. 10 to the 12th, 10 to the minus 5 becomes 10 to the 7th. So notice that in terms of the decibel scale, it doesn't increase that much. 70 and the 74 reach you. Well, which one's going to dominate? The 74 is going to dominate, right? The 74's intensity is a lot bigger than the 70's intensity, right? So then you can see from here that the combined effect is that the decibel scale only goes up by 1, from 74 to 75. So the 70 doesn't really affect the 74 too much, okay? Now that we've done this problem, it's good to cover this topic a little bit. We already mentioned earlier that 80 and 70 decibels, right? 80 is 10 times stronger than 70, and then 90 is 10 times stronger than 80. But it's good to say, well, how does a 70 and a 74 compare? How does 74 and a 75 compare? So we want to compare smaller decibel increments to each other and say, how do they compare to each other? So in order to do that, let's cover this topic. if one sound source, let's say I2, is twice the intensity of another sound source, how much larger will be the decibel scale intensity of the I2 than the I1? So we can convert that to decibel scales. We can say 10 log of, so I2's intensity is twice as strong as I1's intensity. Right? So you can go write it like this. Well, then we could use the law of logs. We can say log of AB is equal to log of A plus the log of B. Right? So what I can do is I can separate this out. This is my A, and then this is my B. Right? So I can say dB is equal to 10 log of 2 plus log of I1 over 1 times 10 to the minus 12. Right? So this is the decibel scale intensity of the second wave, the I2, dB2. Right? So then I can distribute the 10 in there. Right? And then this is dB2. Right? It's the log scale decibel intensity of the second wave, the I2. Right? Well, what does this represent? 10 log of I1 over 1 times 10 to the minus 12. Well, that represents the decibel scale intensity of the I1, right? So dB2 is equal to 10 log of 2 plus dB1, right? So then we just have to calculate what's 10 log of 2, okay? So that's a good ballpark number that we can use to kind of compare, right? So if a certain sound source was 70 decibels, so this is actually not exactly 3 because it's actually 3.010333, but it's very close. 3.010333 like that, 2999566 like that. But it's very close to 3, right? So if a certain sound source is 70 decibels and then another sound source is 73 decibels, this is twice as intense as that, right? And then if this is 76 decibels, so this is twice as intense as that. 76 is twice as intense as 73, and then 79 will be twice as intense. So what is that? 2 times 2 times 2 gives you 8, right? And then how about 80? 80 decibels we already know is 10 times stronger, right? So this one and this one is 10. 10 times stronger. So a 79 is 8 times stronger than a 70. An 80 is 10 times stronger, right? So we should say here 8 times stronger. And then just that one extra decibel is making it from 8 times stronger to 10 times stronger, the intensity, right? Then if you go 3 more, so 79, 3 more, we get 82 decibels. 82 decibels is how many times stronger than 70? So now it'll be another factor of 2. So 8 times 2, that's going to be 16 times stronger. Apply what we learned from here to the problem that we just did. You have a 70 decibel sound source combines with a 74 decibel sound source. So you can see from here that the 74 decibel sound source is stronger than twice, so more than twice as intense as the 70, right? So let's just guesstimate something like 2.5. And then you have, when they join, if this is, the intensity of this is 1, and if the intensity of this is 2.5, when they join, they should be about 3.5 stronger, right? So 3.5 takes you where? Well, 76 is already 4 times stronger than 70. So if a 74 joins with a 70, the combined should not be 4 times stronger, right? So if a 2.5 joins a 1, the combined intensity should be 3.5. Well, 3.5 is roughly going to be something like a 75. So from that ballpark answer, this is about 75 decibel, our answer makes sense. So this is just giving you a ballpark feeling for it, okay? So you can kind of see with this 2-2-2 rule that you can kind of make sense of the answers that you get, okay? Thank you very much.